Bismillahirrahmanirrahim. Assalamu alaikum. Hope you will be fine. In previous lectures, we discussed hybridization, the process of intermixing of atomic orbitals of different shapes and energy to give rise to similar orbitals having equal energy and same shape is called hybridization. In next lecture, we discussed sp3 and sp2 hybridization, while in today's lecture, we will discuss sp hybridization, the process in which one s atomic orbitals combine with one p atomic orbital to give rise a set of two degenerate orbitals is called sp hybridization. The orbital formed will be equal in energy and have the same shape. So, hybridization is basically the property of the atoms which can undergo changes in their orbitals. If we talk about carbon, the ground state electronic configuration of carbon is 1s 2 electrons, 2s 2 electrons, 2px single electron, 2py single electron, while 2pz atomic orbital would be empty. But if it absorbs energy from outside, then it get excited. So 2s electron will be promoted to 2pz atomic orbital that was empty. Then the electronic configuration of carbon is 2s 1 electron, 2px 1 electron, 2py 1 and 2pz single electron. So, what will happen in sp hybridization? One s atomic orbital, you may say particularly 2s atomic orbital with its single electron, will get mixed with 2px with single electron to give rise a set of two hybridized sp orbitals. So, you may say in sp hybridization there will be carbon carbon triple bond, and in order to satisfy the valency of carbon it will have a single bond with hydrogen. if we look at the if we look at the structure of acetylene or ethine, it will have linear geometry and the bond angle will be 180. You can see there are two carbon atoms in which sp hybridization has occurred, and these two carbon atoms will share the same common region of their electron density. So they will give rise to sp hybridization. You can see here that two unhybridized atomic orbitals, those orbitals which did not participate in hybridization, remain perpendicular to the plane of carbon-carbon nuclei, or you may say the line joining the two nuclei. So py and pz atomic orbital will remain perpendicular to the plane of the nuclei. So it will combine with sp hybrid atomic orbital of carbon will combine with one s orbital of hydrogen, and it will give rise to sigma bond as a result of sp2 and s overlap, while your py and pz atomic orbital that were containing single electron will join parallel. The px of one carbon atom will join parallel to the py of another carbon atom and will form a pi bond. So you may see here that the parallel overlapping of atomic orbitals, py atomic orbitals, can give rise to a single pi bond. One thing you must remember: the pi bond is formed between those carbon atoms that are already connected by a sigma bond. So it will give rise to a linear structure, and you may see here that pz atomic orbital that are parallel to each other, they will join sideways and will give rise to another pi bond. So as a result of this, you can say that there are acetylene is a linear molecule in which carbon-carbon single bond is developed by the sp2s sp overlap, and the two pi bond will be formed by joining the sideways overlapping of the atomic orbitals. In next lecture, we will discuss the isomerism of the organic compounds.